I'm going to save this video to the website so that you can refer back to it. So those of you that are watching right now, we are going to go over the quiz. I'll put it up here for 10.4, 10.6 through 10.7. I just want to kind of go through this and kind of help you guys out, and you guys can take notes as you wish to go back and edit. So my goal is that you go back and edit your quiz to see what things you made some mistakes. So those of you that are joining me, if you guys have any questions or you want to chime in, feel free to do that, okay? One thing that I did notice on the Google form that we ran into an issue is that they're not allowing you to do a fraction. So we remember that, did you have that problem?
It happened with the second one.
Okay.
But the rest worked to do fractions.
Okay. So the things that you want to remember is that the scale factor and the perimeter, the ratio of perimeters is exact same thing. So if you have a scale factor of 2/9, this is also 2/9, okay? But then the area, so I noticed on a couple people, I think Matt, you might have made this mistake, is the area is that squared. So 2 squared is 4, and 9 squared gives you 81. Okay. So then on 2, when we're looking at the scale factor and all of that, it's 6 to, what is that? 6 to 10. And 6 to 10 can simplify. So once you simplify it, you get 3/5. So 3/5 is your scale factor and your perimeter. Okay. So these relate to like 2A is the first problem on the Google form. And then 2B would be the second one that you should see. And then 2C would be the third one. Okay, and then this one is when you square both of them. So 3 squared and 5 squared gives you 9/25. So again, in the Google form, this is going to have to be a decimal. So let's see what these decimals are. 3 divided by 5. This one was 0.6. 0.6, and then this was 9 divided by 25, which is 0.36.
So how do you?
Go ahead.
You divide to find like the decimal. Do you divide 3 and 5?
Yes, so you're doing 3 divided by 5, 3 divided by 5, so these are the same, and then 9 divided by 25.
Is the test gonna like be able to do like to keep it in fractions, or you have to put the decimal?
So the test is going to be all multiple choice, and it's going to be all with the answers there given, so you're not going to have to try and plug something in.
Okay.
Okay. So then on 3, this one where it's you're kind of going backwards for this one. So if you know that the area ratios of two triangles are 32 and 98, I first am going to divide both of them by 2. So I'm going to simplify first.
Wait, that's for 3?
That's for 3, yes.
Okay.
Okay, so you're going to simplify first. And you get 16/49.
Yeah.
And then you take the square root of the top and the bottom one. So square root of 16, square root of 49, you get 4/7. And we're going backwards. Here we squared it to go from perimeter to area. Now we're going to go backwards, take the square root of both of them to get the perimeter ratio and the scale factor. And both of those are the same answers.
So I thought you just keep it in 16/49. Oh.
Yeah, that's okay. That's why we're going over it. Okay, so you want to go backwards because you're trying to get to the scale factor. So you do simplify it, but then you got to take the square root of both of them.
Okay.
Okay. All right, moving forward. This is a scale factor. So we have a scale, what does it say? The scale factor of 2 similar parallelograms is 2/3. The area of the smaller one is 40 centimeters squared. Find the area of ratios, or the ratio of the areas, and then find the actual area of the larger. So this is kind of 2 steps. So 4A is, if that's the scale factor, then we're going to square both of them to get the ratio of areas. Okay. So this is the smaller of the 2 parallelograms. This is the larger. This is what represents the larger. So now we're going to do the proportions. So it's 4/9 equals small over large. So small over large equals small over large. This is the small one. So we're putting this in the numerator, and then the denominator is the unknown. And then we cross them over.
Wait, you have to do, because I was doing 2/3 equals 40/x. So you have to,
Yeah.
you have to
So you
square
gotta get
2
the
and 3.
area, because this is just the scale factor. Remember, we're talking about area. Here's our key word right here. We're talking about area, so we got to find the area ratios first. So that's why we had to square them first.
Okay.
Okay.
2/3.
Matt, are you writing this down or anything like that so that you can use this to help you? Send me a chat or something like that. Let me know what you're doing. Okay, we ready to move on to the next one?
Yeah.
You good?
Number 5, the next.
Okay, so these ones are talking about major and minor arcs. So the minor arcs are anything less than 180 degrees, so less than 180. Whereas the major arcs are going to be above 180, and then the semicircle is the ones that equal to 180. So less than 180, minor arcs are also, a hint for minor arcs is going to be that there's just going to be 2 letters. So minor arc would be like this from here to here. So it'd be like, what is that? Is that H? I can't tell that letter. That's H, yeah. H to M, or we could do H to T. But once we go across even more, then it's not going to be, we're going to too much. Okay, so less than
Like a semi.
for minor. Major arcs is when we kind of loop around. So major arcs would be something like T, H, and all the way around to A, something like that.
Mhm.
Okay, a major arc would also be M to, what is this, T to U, or to H, I mean, sorry, all the way around here. So it has to go more than 180 degrees. Okay, and
So,
go ahead.
so I got MTA for the major arc, but MTA.
MTA.
Why is it?
Yeah,
It's not like all the way around. Like goes weird. It goes
well,
like,
MTA should be a major arc. So that is correct. M, T to A, because you're going 180 degrees and then a little bit more. But if you did M, A, T, you did
that would be a semicircle.
TA, right? Yeah, exactly. MAT is a semicircle.
Okay.
Okay.
So it's just the order that matters a lot.
Exactly. The order does matter for sure.
Yeah.
Okay. All right. So then the last one on this page is just find the measure of each arc. So Y to V. So if I'm looking here, Y to V, I'm always looking to see, and I kind of have examples over here. I'm always looking to see, like this is a half circle, is 180 degrees.
Mhm.
The entire circle is 360. So I kind of look to see what I have. So this one here, this is, let's see, Y to V. This one right here. So if I look here in this kind of like orangish color, pinkish color, that's 180 degrees. So I did 180 minus 77 to get 103.
Mhm.
And then V to Z, yeah?
Yeah.
Okay. So then V to Z, that's this one right here. So I did this in blue. I said, okay, well, this is a half circle all the way around. So 180 minus 120 is going to give me the 60 degrees here. Okay, so this one here, let's see, we said this was 103. I'm going to put this out here. So now we've kind of got all of our numbers. So we've got 60 here, 120 here, 77 here, and 103 here. So the last ones, we're kind of adding things together. Like if we do Z to Y, Z to Y, we're going to include all of this. So this is going to be 60 plus 103. So 60 plus 103 gives us the 163.
Mhm.
Okay, and then this one, X, Z this way to V, that's going to be a semicircle. So semicircles are 180. And then the last one here is YXB. So Y, X, let's see, where's X? And all the way around to V. So I added 77 plus 120 plus 60 to get to 257.
Okay. Yeah.
All right, let's move to the back. Okay, and I'll be posting this picture of the like answer key as well.
Okay.
Unfortunately, I've only got like 8 more minutes and then I got to log on with my Algebra 1 class. I could probably go
Okay.
a little bit, but this one was just really using the formula. So like this is circumference. So pi times diameter. You just have to check to see, do I have my diameter? So remember yesterday we're kind of talking about how do you know which formula to use? It all depends on what you've been given. So in this case,
Mhm.
I have 11 as my radius. So if I double that, that's how I get the 22 pi.
Yeah, and the thing you put on top, like the area of a circle, that helped a lot to
Oh,
like
good.
see what the thing
Awesome.
to help.
Okay, and then
Cool.
these ones are talking about arc length. When we're talking about arc length, we're still talking about circumference. So that's why we're using that formula arc length. Are these ones. Oops, let me move it down a little bit. So you're doing degree over 360 times 2 pi r, or pi times diameter, whatever you've been given. Now it looks like in this case we have radius, so that's why we're using r. So the biggest thing here is making sure that you have the work done correctly in your calculator. Okay, so
Mhm.
it's 60 degrees, so we're trying to find this piece right here. So it's 60 divided by 360 times 2 pi, and your radius is 20. So when you multiply 2 times 20, you get 40. And then from here, I just used a calculator. 6 divided by 36 times 40. So you'll get 20 over 3 in the calculator, which simplifies to 6.7 pi.
Wait, which one was that for?
That one was for number 15.
Oh, yeah, okay. 15.
Mhm. And then 16 is the same type of problem. The key is knowing what your degree is. So this here should be 270 degrees, because if that's 90, I can do 360 minus 90 to get to that 270. So I'm just
Okay.
going to move up to the area ones. Okay, so area is pi r squared. So we just got to make sure that we have that information. So we've been given the radius in 17 of
Mhm.
6. So 6 squared gave us the 36. Leave in terms of pi. But this one, we've been given our diameter, so we had to half it. So half our diameter is 14. And 14 squared gave us the 196.
Yeah.
Okay. And then the last ones here, these were the ones where we did the learning online, really. This was the one where talking about area of a sector. And it has it up top, but I'll write the formula here. It's degree over 360 times pi r squared. And in some cases, like number 11 and, or sorry, 21 and 22, you're having to either take away pieces or add pieces together.
Yeah.
So,
And I have a question for number 20.
okay, what's up?
So, So it gives you like the correct answers. Oh, okay, those are the same. I'm trying to figure out why I got it wrong.
Which one, number 20?
Yeah,
What
because
answer did you put in?
I got 96.
96. Okay.
Yeah.
Was that a possible answer, or was it a fill in the blank answer?
It was a fill in the blank one.
Okay.
I think I just like did it in the calculator wrong.
Yeah, so I would just make sure you do 300. So I would do 300 divided by 360 equals, and then we're going to multiply that by 24 pi. So, or sorry, 24 squared. So I'm going to just do 24 times 24 to make it easier. Yeah, so it should be 480. So I would guess that it's probably a calculator error that you had.
So 360 minus 60. Okay. So 360, you minus it by the whole thing.
Yeah, because we were just given this little piece here. So I just said, well, if we're trying to find the area of all of this, then that piece is going to have a degree of 360 minus the 60 that we've been given.
Yeah.
Okay.
Because I did 60 divided by 360.
Oh, that's why. Yeah. So what you found the area of this little piece. You found the area of this little piece instead of this big piece. We want like the Pac-Man piece.
Okay.
Okay. You found the area of the little piece. Yeah. So your process is right. It's just that you've got to find the right degree in what we're looking for as far as the area goes.
Okay.
Okay. And then the last two, how'd you do on the last two?
Those right.
Yay. Good job,
Because they're kind of easier. Thank you. They're kind of easier because like you don't have to keep going. So it's like you just have to.
Yeah, you get to
like,
stop where they, yeah. But still finding
Those
out what you got to do. So this one here, we found the area of this, and then you took away. So we found the area of this piece, the whole thing. And then you took away the area of the triangle, right?
Yeah.
Yeah, looks good. Okay, and then this one was the square minus the circle. So area of the square minus the circle, just so I have it on there for everybody else. Okay. So, Gianna, if you can, try to go back. Let me just stop this really quick.